Hi there, welcome back. In this module, I'm going to introduce you to your best friend on your journey to a serverless future. And the name of that best friend is the Serverless framework. We're going to cover the basics of the Serverless framework, which is a popular deployment framework for functions as a service. And it supports a number of providers, including AWS Lambda, Azure Function, and Google Cloud Functions. To see the full list of supported providers, you should go to the link on your screen right now. It automates the process of packaging, deploying, and versioning Lambda functions, as well as creating and configuring those event sources, such as setting up and deploying API Gateway APIs. And it does all of this with a very simple command line interface. It makes configuring and managing your Lambda functions very simple, and you also get a number of good practices out of the box. For example, it enforces a consistent naming convention, which makes functions easier to find and manage. And you can find closely related functions by prefix as well. This naming convention becomes very important when you have to manage hundreds of functions inside an AWS environment. And to follow along the demos in this module, you should install the Serverless framework by going to the link on your screen right now. I will also be using Visual Studio Code in my demo, so if you haven't installed it yet and want to follow along exactly as I do, then you can install Visual Studio Code by going to the link on your screen right now. Alright, now you're ready to begin. Let's start by why I think the Serverless framework is a good choice over other frameworks available in the market. As symptomatic of any new hyped up technologies, AWS Lambda has inspired a host of deployment frameworks, and Amazon Web Services itself has published their own SAM framework, short for Serverless Application Model. And it frustrates me to keep reading about others writing their own bespoke deployment scripts for Lambda, which are often poorly thought out because it's their first time working with Lambda. So, a word of advice, don't do that. That's precisely the kind of undifferentiated heavy lifting that we want to move away with Lambda. Instead, pick one of the existing frameworks that works best for your workflow and insist it upon your engineering team. You want to build up knowledge of your framework of choice in the team so people can help each other. And as people move around projects, they know exactly how to deploy things and can spend their time and effort on more important things, like getting up to speed with the code base and the new problem domain. Having tried a few of the aforementioned frameworks, I made a decision to go with the Serverless framework early on and has stuck with it ever since. And one of the reasons is that it's backed by a commercial company with financial funding and full-time staff working on a framework, so it's likely to see constant improvements and bug fixes. And it's likely to be around for a while, so I don't have to worry about building my system on top of an abandoned framework. And besides the financial backing, it also has a lot of community support. In fact, a lot of the good practices that are baked into the framework have come from feedbacks by the community, and many of the current features have been proposed and implemented by members of the community as well. And being one of the first frameworks on the market, it's already seen a complete overhaul with the 1.0 release and addressed many of the problems with the first version. And as part of the 1.0 release, it also introduced the multi-cloud support. But this multi-cloud support is not a silver bullet to make cloud migration projects easy. With Lambda, your locked-in is not with the function itself. Compute has always been easy to move around. What locks you in with AWS Lambda is the ecosystem. It's the databases, the blob storage, and the queues and streams that you have designed your application around, and with terabytes of live data that you need to migrate whilst keeping your system active and running. And it's all the code that you don't have to write yourself, like the code that invokes your function when an API endpoint is called or when an event is pushed into Kinesis, or the code that handles the retries when a batch of Kinesis records cannot be processed. Instead, the value of this multi-cloud support lies in the ability to use the same tool as you move to a different provider. The same way that Terraform gives you a consistent tooling experience when you move from one provider to another, even if you have to use a different set of syntax in your Terraform scripts, at least you don't have to learn a new orchestration tool on top of everything else. So let's see how we can use the Serverless framework to quickly create an API with API Gateway and Lambda. So first, let's create a folder for our project, and we will call it hello Manning, and we will go into that folder we just created. We can use the serverless framework to create a new project. If we don't specify the template we want to create our project with, it will tell us that we're doing something wrong and give us a list of the available templates. So let's try this again. Serverless create TAWS Node.js. Okay, so now we have created skeleton for a new serverless project. So we can open up in Visual Studio Code. As you can see, we have a couple of files here. It's by default created a git ignore file for us and a handler file where our handler function is defined. And it has also created a serverless.yaml file that we can use to configure our function. First thing we do, we change the name of the service to hello Manning. If we scroll down to the function section, we can see there's a function here called hello with the handler pointing to a hello function that's been exported by the handler module. Like the example down below, we can create a new event source for this function, and we use HTTP, which creates an API gateway event source for this function. Path, we use the root method, we use get, and we save. And that's all we need to do to create an API with API gateway and Lambda using the serverless framework. Again, we use serverless, or in fact, we can use the shorthand SLS, and we can use serverless deploy command to deploy this function to an environment. In the background, it's packaging my code as well as all its dependencies and using CloudFormation to create the stack for my function as well as the API gateway configuration. And you deploy the API for me as well as my function. The deployment will just take a moment as the CloudFormation stack is being created. Okay, and the deployment is done. From here, we can actually call the endpoint straight away. We can see it works. If we go back to our handler code and we make a small change, I don't like to see the event being reported. And I want to change this to hello Manning. I can redeploy my function again with SLS deploy. This time it will be a lot faster because you just need to update the existing CloudFormation stack rather than create a new one from scratch. Okay, and the deployment is done. You can see our change has been reflected. Great. See how easy that was? Let's spend a few moments to go through the structure of the serverless.yaml file. Once you delete all the commented out bits of the serverless.yaml file that came with the template, you'll end up with something like this, which is close to the minimal set of information you need. First, the serverless framework has a concept of a service, which is just a way to group related functions together. It allows you to share code between functions easier, and when you deploy, all the functions in the service are also deployed together as a unit. You then have a provider section, which has properties that are specific to the provider. And then you have the functions section, where you configure the individual functions, their name, their path to the handler function, and event sources, and so on. The handler property is a relative path to the module file, relative to the location of the serverless.yaml file, followed by the name of an exported function in the module, which takes in 3 parameters: the invocation event, the invocation context, which contains metadata about the invocation, such as the number of milliseconds left, and a callback function. We'll look at this in more detail later on in the course. You can also add 1 or more event sources for your function in the events section. By default, the serverless framework will configure a function with 1 gig of memory and a timeout of 6 seconds. You can override these default settings by specifying a timeout and memory for a particular function. Or you can override the default for all the functions in this service by specifying timeout and memory in the provider section instead. To recap, in this module we discussed why you should consider using the serverless framework, and we saw how easily you can create a new API with both API Gateway and Lambda using the serverless framework. And we went over the basic structure of the serverless.yaml file, which we expand upon in the next couple of modules. But we kind of left a big elephant in the room, which is how do you manage the permissions required to deploy your project using the serverless framework. So in the next module, we are going to go into that in detail. And we're going to explain why it's not such a simple question to answer and the common strategy that people have adopted in the community.